if you were looking at this notation right here, okay, what this is telling you is that we're looking for the set of all x's such that, and then the inequality, x is less than or equal to -6, or x is greater than or equal to -1. So really this is just another way of representing that inequality form of the intervals. Okay, and so if you're converting this into its interval notation, how many different intervals are you looking at here? You see an or tells you that it's split up. Okay? And so if you look at the graph for this, if you were to imagine, and often it's easiest to represent it in terms of a graph and then go back and find the interval for it. But here x is less than or equal to -6, so you have one critical point at -6. The arrow points to the left, so it's this set. It has an equal to, so if you put an equal to on your graph, notice it creates that bracket. And then your other critical point is -1, which from left to right is going to be to the right of -6, right? And now our arrow, x is greater than, so the arrow goes this way, greater than. It has an equal to, so we put an equal to on our critical point. And so here we are able to see what that graphical representation looks like. And once we have the graphical representation, we can express it as an interval. We have these two separate intervals here. We go from -infinity all the way to -6, and then from -1 all the way to infinity. So these are the intervals that we'll use. Always parentheses at the infinities to -6, bracket here, bracket at -1, always a parentheses at the infinities. And because we have multiple intervals, we will put a capital U, okay, for the sake of how we enter it, but a union of sets symbol is what we would use to represent that. All right. Looking at the next one, we have an excluded value. So our domain set, or the set for this solution here, is the set of all points, all x's, such that x is not equal to 6. Okay, so when you're looking at this, this set right here, the set of all x's such that x is not equal to 6, how do you think you can express that using interval notation? Okay, on your number line here, you have one critical point at 6. Okay, it's everything up to 6, but not including it, everything past 6, but not including it. And so if you're thinking of what that looks like here, we go from -infinity all the way to 6, and then from 6 all the way to infinity. So you can see here that even though we're just excluding one value, we're representing it with two intervals, and the intervals go all the way up to, but do not include the 6. Okay, so -infinity up to 6, not including it, from 6 to infinity, but not including it, because it's two intervals, will include the union of sets symbol. And so this is the way that you would express x is all real numbers except for 6. Okay, so we have this double unbounded inequality or interval. We have this, again, double unbounded inequality or interval. The final one is a bounded interval. It's between two values. So again, if we're looking on the number line, critical point at 0 and at 1, there's an equal to at each of these. So if we draw our equal to's in that sketch of our graph, we have brackets facing each other. And so this is our interval set. And if we express it in the interval notation, we go from 0 to 1, brackets at each. Okay, and so that would be your final way to express that interval.